Hey folks, welcome back to another video. Today we're looking at question 2196, create binary tree from descriptions. The way we'll be approaching this problem is by using a hash map to keep a track of the value that we see, mapping to the tree node so that we can easily retrieve it. And we'll keep a set of, like a hash set that will keep a track of all of the children nodes. So in the end, when the tree has been constructed, we just need to iterate through it and see which value doesn't have like a corresponding value in the hash set. That means that is a parent, and that's when you return that node. So let's get started. First we need a hash map. It'll be int and tree node. Let's just call that map, new hash map. Right, and the other thing we need is a set, and then just store integers in it, then call it child values, new hash set. Okay, after this we'll iterate through all of the descriptions. Just call this D and go all the way through descriptions. Let's extract the values. So from the example here, 20 is the parent, so let's do int parent is equal to d of 0, int child is equal to d of 1, and boolean is left is equal to d of 2 if it is equal to 1. Awesome. So what you do is, if you basically need to check if these nodes exist already. So if map that contains key parent, so there are actually two things that we need to check. Yeah, and if it contains a parent and the child, you just need to connect them. So if is left, if it is a left child, then what you do is map.get parent dot left, I think. Yeah, dot left is equal to map.getChild. So basically what you're doing here is that we know that both of these nodes exist already. That means they have been like created previously, and both of them exist. Therefore, you just check whether you need to attach it to the left or the right. And the way you check is that if it is the left child, you tell, okay, get the get the tree node that's associated with the parent and put the left child as the like the left node, like the child node that you retrieve from the tree. If it is not, you just basically do that on the right. I think these are the right methods, but we can check that. So if this is not the case, so only one of these like you need to check if one of these conditions hold or both of these conditions hold. So if map.key contains key, if this is not yeah, map dot put parent and new tree node with value parent. Actually, I think we can simplify this. If we extract this here, you're basically checking, hey, if the parent node doesn't exist, create a node for it and add that in the map. And if the child node doesn't exist, do the same with the child. And that way you don't have to have these complicated conditions where you check, hey, does the parent exist? Does the child exist? So this should simplify it. Wait. Yeah, okay. So I think that gets taken care of, like attaching it. And where does this stop? Okay. And in the end, what you need to do is you need to add the child values. So the child values dot add child. And we'll understand why we need that in a second. So for int c in child values, if the map doesn't contain key child, that means it's not one of the child nodes. If it doesn't contain, so if it doesn't contain C, that means that is the root node. So you would return map.get C. So that's basically returning the tree value. So basically like the head of the node. And in the end, we still need the return statement here, but this is just to make sure that all the base cases are covered. So in the end, you just return no. Okay, let's try compiling this to see if there are any bugs. And I think we need to put it in as like a full integer. Okay, let's try that again. I'm sure there are some issues. Right, I wonder. Tree. To assign it rather than giving it as a method. So let's try that again. Okay, where did we go wrong? I wonder if it's returning here. Let's try that. So basically what I'm trying to do here is trying to figure out whether it's returning not from here or actually none of this is happening. Let's try that again. Okay, yeah, so basically it is reaching all the way over here. So all of the child values, let's try that again. So 15 has been added, 17 has been added, 20, 18, 19. So all of the child nodes are being added. So for all of the values in the hash map, but actually it's the other way around. So because the tree node is not in the child value itself, it will actually be the other way around. So it would be for int node value in map.get keys, I think it is. So if child values does not contain C, that means you would have to return map C. Okay, so I think this is correct. Wait. Yeah, here. So this goes out, and I think this is map dot keys map dot keys, I think it is. Let's try that again. Oh, right. Map dot get keys. Ugh. And let's just quickly Google the shall we map get keys Java. So basically key set. Okay, let's go back. Key set. Okay, let's try that again. Okay, the first test case passes. Everything else passes as well. Okay, awesome. So let's talk about the space and the time complexity of the entire solution. The time complexity of the entire solution is of n, since we are iterating through every single description that's given to us. The space complexity is also of n, since we are using space to store not just like the mapping between the values and the tree nodes, but also like the child values. Awesome. If you have any questions, please let me know in the comments below. Don't forget to don't forget to subscribe to the channel and like the video. I'd really appreciate that. It keeps me motivated to make more videos. Thanks so much, and I'll see you folks soon. Peace.